This is a release FRQ from year 2007, and we can use calculator for this problem. So when a certain grocery store opens, it has 50 pounds of banana on display table. Customer removes banana from the display table at a rate. So this is the rate of change. So f of t is the rate of change, and that's how fast the bananas are being removed from the table. And f of t is measured in pounds per hour. T is the number of hours after the store opened. After the store has opened for 3 hours, store employees add banana to the display table at a rate given by g of t. So g of t again is a rate of change, and this one is how fast the employees adding the banana onto the table. And g of t is measured pounds per hour, and t is the number of hours after the store opened. So the first question is how many pounds of banana are removed from the display during the first 2 hours the store is open. So in this case, we don't really need to figure out how much is being added or how much do we have originally. We just need to figure out how many pounds of bananas are removed. Okay, so we're just going to use this function right over there. And since f of t is a rate of change and we want to figure out how many pounds, we're going to take the antiderivative of f of t dt from time 0 to time 2. And we don't have to do this by hand, we can just plug it in your calculator. Okay, so when you're using your calculator, make sure you check that you're in radian mode unless the problem specify otherwise. So let's plug in f of t into y sub 1. So 10 plus 0.8 x sine of x cubed. So we're going to make a fraction bar right over there. X cubed over 100. And since we know we're still going to need the second equation g of t anyway, so might as well just put it in now. 3 plus 2.4 natural log of x squared plus 2x. So now let's go back to the home screen. So we're taking the antiderivative, so math 9, from 0 to 2, and we put f of t under y sub 1, so that's alpha trace to go to y sub 1, and we're taking the antiderivative in terms of x. So this one will give us approximately equal to 20.0511. So we need at least 3 decimal places. If you give more than 3 decimal places, it's okay, as long as don't give them less. So now let's move on to B. It's asking us to find f prime, which means the derivative of f, when t is equal to 7. Then using correct units, explain the meaning of this in this context. And since this is a calculator problem, all you have to show for your work is f prime of 7, and then now you can just plug it in your calculator. So we want to take the derivative of f, which we put under y sub 1. Okay. So we go to math 8. We need a function of x, y sub 1, and then plug in 7 for x when you have taken the derivative. So f prime of 7 would equal to negative 8.119, or they will accept negative 8.120 if you round it off. Part B also asks us to explain the meaning of f prime. So this is the derivative of f, so the rate of change of f. And f is the rate at which customers remove bananas from the table. So f prime of 7 is the rate. So this is the rate at which customers remove banana from the table is decreasing by 8.119 pounds per hour squared. Now the unit is pounds per hour squared because we know f prime is just the slope, which is change in y all over change in x. And in this case, f of t is measured with pounds per hour. And x, which is t in this case, is hour. So if you simplify, it's pounds per hour squared. So now let's move on to part C. Is the number of pounds of bananas on the table increasing or decreasing at the time t equal to 5? And give reason for your answer. So let's say we have the table and some bananas being removed, and we're adding some more banana on top of the table. So if there's more bananas being added and less bananas being taken out, that means the banana on top of the table is actually increasing. If there's less banana being added and more banana being removed, then that means the number of bananas here on the table is going to be decreasing. So we need to compare f and g to see which one is faster at time 5. So we plug in 5 to both f and g to see which one is faster and which one is slower, and we're going to use our calculator to figure it out for us. So all we need to do is plug it in. So y1 of 5 and remember y sub 1 is f. So f of 5 is equal to 13.7959, and g is in y sub 2, so y sub 2 of 5 is equal to 11.5328. So if we compare these two numbers right here, this one is bigger. So since f of 5 is bigger than g of 5, then the number of bananas on the table is actually decreasing. So now, part D, how many pounds of bananas are on the table at time t equal to 8? So first we need to figure out how many pounds of banana we have originally. So we have 50 pounds of banana originally, and there's some number of pounds of banana being removed, and there's banana being added. So the number of banana is going to equal to 50 plus the number of banana added minus the number of pounds of banana removed. This will equal to 50 plus, since both f and g are rate, we're going to take the integral of g of t dt from time 3 all the way to time 8 minus the integral of f of t dt from time 0 to time 8. So that's all the work you need to show, and then let the calculator do the rest. So we have 50 plus the integral, so math 9, from 3 to 8. And remember g of t, we plug it into y sub 2. Okay, dx minus the integral, so math 9 again, from time 0 to time 8 of f of t, which we plug into y sub 1. And this would give us 23.347 pounds of banana at time t equal to 8. And that's it. Yay, we made it. So the scoring guideline for this problem right here, okay, again, a set of problem is always out of 9 points. And for part A, 1 point for the integral, 1 point for the answer key. So as long as you have this integral, you got a point. The answer is another point. The explanation, you do not have to do it since they did not ask for an explanation. For part B, you have the value. So as long as you have one of this, and then another point for the meaning. If you consider f of 5 and g of 5, then you get a point, and your answer is also a point. And if you notice that the way we explained earlier, we have f of 5 is greater than g of 5, which technically means the same thing as that, so we'll still get that answer credit. And then the last one, we have 2 points for the integral. So as long as you have something like this, that's 2 points, and then your answer is another point. Alright, so now it is really done.